Hey cats! Next we're going to take a look at this is a 70s Ampeg SVT, one of the most iconic bass amps of all time. So popular that they've reused the names for a whole bunch of other things, but SVT actually stands for Super Valve Technology. These amps were immortalized when the Rolling Stones were on tour in the US, and because England uses 220 or 240 50 hertz, their power converters were set up wrong and they burned up their amps. I don't know if they had Marshalls or Voxes, I'm not sure. But in New Jersey, where Ampeg was, when this happened, they got a call, and these were still in the prototype stage. 300 to 350 watts of pure tube power, and they brought a bunch of these in, and the Stones toured with them, and they became totally iconic. This is a relatively early one from the 70s. Once I open it up, we'll find out what year it is. We can tell by reading the transformer and pot codes. It's from a wonderful backline company who I repair stuff for. And I was told that input 1, or the first channel on this, is cutting in and out from vibration. And channel 2 is working okay. So this has a separate power amp and preamp section. I'm not going to do a full service on this amp like I normally do. This just has to be repaired and turned around. It's late at night right now, and I have to get up in the morning for work, and I've got to get it back to him by tomorrow night. So I'm going to pop it open. First, I'm going to verify what's the matter with it, and I'm probably just going to pull the preamp on this and find out what's wrong in there and fix it and put it back together, unless there's something, and I'll probably bias it and balance it, so you'll get to see that. So let's dive into this thing, but I just want to tell you, it's not one of my normal service jobs. This is just get this thing fixed and back on the road. These are fun for old guys because I think it weighs 94 pounds actually. These older ones are not too bad to service. The new ones, the Loud Technologies versions, I have to tell you, are one of the most difficult to service amplifiers that I work on. I really would love to know all the bands who've used this over the years. I think it's been a rental for a long time. I don't know, maybe 20 years. The amp's certainly older than that. A lot of screws. This whole amplifier is built pretty much like a World War II tank. It's heavy, it's powerful. The plate voltages are outrageous. This is not an amplifier for a beginner. I would not recommend that your first foray into working on tube amplifiers is an SVT. This baby has some miles on it. It looks like the inside looks pretty much like an ashtray. As I said, they're a two-piece chassis, and this one has been already pretty heavily modified. Most of the original plugs went out in these things pretty quickly. So people put different plugs inside the chassis to get them to wire them, and I've done quite a few myself. It's got a full-time cooling fan, which is great for it not blowing up and burning out, but it's horrendous for the amount of dirt that's inside this thing. Plus this gets used at festivals and so forth, so it's really a mess inside. We can see that it has 6 output tubes, and this is pretty interesting because this thing has 2 different brands of output tubes in, and that's pretty unusual to see in one of these things. I'm going to fire it up, hook up a speaker, and try to reproduce the problem they're having, because it may be as simple as a tube coming out of a socket. We'll see. Most of these have had their speaker outputs rewired and their standby switches. Originally, the cabinet had a jumper in it, so your speaker cable had 4 wires. 2 of them were actually to kick the standby out, so you didn't accidentally run these without a speaker. The originals would blow up really fast. The original output tubes could not handle the voltage of no speaker connected. And even these here, if you run one of these with a bad speaker cable, it'll blow fuses, at least. and at worst it arcs your output tubes out. This is a very expensive set of tubes here. It has some Savtech WEs, 6550 WEs, which are used in the newer ones, and I'm not going to pull these right now, but these other tubes may, oh, they're 6550s too. They're just older ones that are shaped differently. So anyway, I've got a speaker in this thing. I'm going to use a tone generator rather than a guitar to test this the first time through, because I've got enough stuff here to mess with it. Again, I need to get this thing fixed as quickly as possible, back on the road, and we'll save a complete service for another day if it needs it. I don't know if you heard that, but the entire city just dimmed when I hit the standby switch on this. It pretty much took the power plant down almost. One of my 412s I use for a test cabinet has very rattly speakers because I got carried away one night with one of these. I love the way these sound with guitars. I'm not touching anything near voltage in here. I'm wiggling tubes. Alright, there we go. So one problem is we have an intermittent tube socket. This is an old-fashioned circuit board in here, so I don't know if it's the PC board or whether it's the socket right now. We'll find that out in a minute. Okay, it looks like we have an input jack problem too. So I'm going to have to tear down the preamp on this. I'm not going to mess with the power amp. We're going to try to get the preamp chassis out without pulling the whole chassis. Just depends upon if I can get a screwdriver in there to loosen up the screws with everything in here. We're going to power this thing down. And again, I'm going to power it down and leave the standby on to let this thing drain down a little bit. If there's ever been an amp that you don't want to mess with hot or with the capacitors charged, it's an SVT or a Marshall Major. They run tremendously high current, voltage to the output tube plates. Getting pretty warm in there already. Okay, this is good news. So we're going to be able to pull this chassis. I have to move everything because the chassis comes out of the front. It looks like, you can see how rusty this poor old amp is. I can't wait to see what year it is. We'll look at it when we get the chassis out to see. As I said, I'm guessing from the way it's painted, it might be a 73 or a 71 to 72, but I'm not sure. That's beautiful. We have to be very careful. We've got a very old cable. Now this amp has not been discharged yet. The capacitors haven't been discharged, so I have to be careful and check everything as soon as I get the cover off. Oh my Lord in heaven. Oh my goodness. The tar pits of Lamberea right here. Woohoo. Okay, so let me first of all kill the power in this thing. The power feed to the top part of the amp is right here. I'm going to check it. I'd like to support this here a little better. Like I said, normally when I do a full service on this amp, I pull the whole chassis, bottom chassis out. Everything sits up here on the bench out of the box, but not tonight. Tonight is get this thing working. Make sure it's ready for a show, because this could be completely and thoroughly washed. We could do a whole series on how to service these things. They have some very unusual features. I do a lot of them. I think maybe because a lot of people don't like working on them. Yeah, so we're in good shape on this. It's discharged. The approach that I'm going to take right now is I'm going to thoroughly and completely clean the tube sockets in this, and then I believe there's a problem over on the input side with the wiring to the jack. I'll take a look at that in a minute, and we'll move the camera over there and make sure we've got this thing straightened out. They thought it might need tubes. This uses some tubes that people don't keep around. I work on a lot of them, 6E04 and some 12 DW7s, or they're also called ECC 832s or 823s. The 6C4 is just a 6C4. They're available new old stock, and they have a tendency to get really noisy, but I have a few of them in stock, so we should be in good shape on this amp. First thing is, we're going to pull these tubes and clean the sockets. These have kind of a funny sort of shield on them. And I'm not pulling these all out at once. Yes, the 12 DW7. I'm only pulling these out one at a time. And I'm only going to pull out these tubes one at a time. And I'm going to get a different kind of cleaner for these sockets. It's actually deoxit. And these are too hard to get at, to mess around with. And they're extremely high quality components, these amps. These sockets are fantastic. So I don't mind using a better cleaner on them. I don't have to worry about pulling plating or anything, because these are when tube technology was kind of at its finest. It was near the end, but that's when they were the very best. And then I'm going to clean this board a little bit. This is a disaster area. This socket actually is a little bit eroded. I'm not polishing the amp, I dripped some deoxit on it. And I don't want it dirty. I'm going to clean the circuit board with this other stuff. I'm just going to do a rinse down. Nice. These wires break really off. I mean, I can't say really often since the since the amplifier's what, 51 years old. Oh my Lord, doesn't seem that long ago. But yeah, 69 was. That's when it was designed. Let's see what year it is. See if I can get a component and pull a date off something. I think I found out what's wrong. It looks like there is a broken insulation that's allowing the input to actually short to the chassis and kill the input signal. As a matter of fact, you know what? If I put this right here, all I have to do is tie wrap this right here, and I'm 99% sure that all of our problems will be over. Because this will keep it off the chassis, and it will probably stop the intermittency. And these amps are incredible though, but they're a very sort of unusual design. Ampeg had some free thinkers working for them, that's for sure. And their claim to fame was not distortion. It was super clean bass amps. In the old days when I played a lot, my amp for years was an Ampeg VT22. It's like the Fender twin of Ampegs, but just a superior amplifier in every way. But again, very expensive to fix just because they're built like beautifully. I mean, this thing still has, they use such high quality components. This has 50-year-old capacitors in it still that are running. And it sure didn't sound very noisy for an Ampeg SVT. These SVTs are hummy. They have hum in them because of the separate chassis here. The way they're wired, they pick up hum. They also have a hum balance pot, which it's not unusual for that to go bad, and then they get really noisy. So if you ever have an Ampeg SVT, these old ones come in, you know, up till 1978 or so, that's extremely noisy, always check to see if the hum balance pot is good, which we'll take a look at in a minute. I want to see if we have this thing fixed. What we're going to do now is, I didn't unplug anything or anything. I'm going to leave this thing, believe it or not, actually hanging kind of like this. Brace this up right here. And I'm going to fire it up like this and see whether it seems like the preamp is solid or if it's intermittent. The top part of the amp, I mean, we still have to be careful. I still have to be careful. It's running a few hundred volts up, but it's not like the power amp section, but it's like really, really high voltage. I'm gonna throw that output tube back in that I took out. Okay, this should be fine, even though it's kind of laying sideways here and stuff. I'm going to take it out of standby, make sure the volumes are down all the way. Plug in the speaker first. Ultra high switch. The bright's working well. May seem like I'm being abusive, but most of the problems with amps like this age are mechanical. And I've just got to let this run for a while because they said that it was intermittent and the volume was changing, and maybe after it gets hot. I'm going to try the other input jack for one. And there were no complaints about channel 2. It was all channel 1. So I'm going to grab a heat gun and warm this mess up and find out whether it makes a difference. That smells pretty bad heating it up. I'm going to take it up to about 180 degrees Fahrenheit, by the way. We're up to 160. I want to point out, if the metal tip of this gun hits the circuit board, that wouldn't be a good idea. Okay, we're up to 180 on the channel 1 side here. Okay, great. Whoops. Now we're going to, if you think that noise is irritating, you ought to be here. As a matter of fact, let's make it a little more pleasant. How's that? So I think we're in pretty good shape on this. Again, the problem was, there were 2 things that could have been causing the problem, but this wire, the input wire, was definitely hitting the chassis. I moved it, tie wrapped it out of the way so it won't bump into it anymore, and that would be the main reason it was changing volume. I'm going to check channel 2 just to be sure, but we have no other loose connections in here, and of course the tubes were coming in and out of their sockets too. This amp is dirty. But like I said, they need it back, so we're going to check channel 2, put it back together. Again, I'll let the thing run probably for 20 minutes and keep testing it. But I'm going to try the other channel here. The tone controls on SVTs are outrageous. All the different sounds you can get out of it. And the mid-range is actually switchable. There are inductors on here. It's pretty much an active tone control. Not pretty much, it is an active tone control circuit. This thing is now completely solid. Before, when we hit it, it was cutting in and out. I'm going to bolt it back together and tell them that after the season's over, this one's due for a pretty major tune-up. But for right now, we've got it working. 50-year-old amp, and probably good for another 50. Part of the trick now is to bolt this back together. I'm going to discharge. I'm going to unplug it. I've turned it off. I'm going to discharge the high voltage. When I do this, you'll never hear a snap, crackle, or pop because I'm using a 1000 or a 1K ohm resistor to drain the power out. It just saves a lot of wear and tear. So, in summary, we found some intermittent tubes. I found a wire touching the chassis. I've tie wrapped it out of the way. As I said, this is a quick repair. Okay, well, I've spared you all the pain of watching me try to reach through here and get the upper chassis mount screws in, but we're all set. What I'm going to do now is put the back on, and I will turn it around and show you quickly how we set the hum balance and the bias and balance on the output section of an SVT. Okay, we're going to get this SVT set up to check and adjust the bias and the balances on it. This front panel just pops off. It's held on with some giant, like plastic Velcro things. And this is nice because it's written right on the front exactly how everything gets adjusted, okay? And to do it properly, you do need a dummy load and an oscilloscope. Okay, what we're going to do right now is we're going to set the bias and balance on the SVT. With no signal and the volume controls all the way down, I have a 4 ohm dummy load hooked up to it. We'll set the voltmeter to volts DC. It's kind of in the picture here. We'll set it over here. So hopefully you all can see it. Yeah, you can. And there's a ground point, and then there's a test point for each bank. And we adjust, this is simple. We adjust both of these. It's been warmed up for a long time. We adjust these to 75 millivolts. Very nice. There's one. And the other thing you can do is you can adjust between for 0 between the two. And then we'll double check it. .72 on that one. About 73. About 73. One affects the other a little bit because it loads the bias circuit. And on this amp, we're actually not setting the bias on the output tubes. We're setting the bias on the driver tubes, which are coupled to the output tubes to set the bias. It's not like most amplifiers. It's SVT, super valve technology. And these are lovely, like I said. They're just probably the most expensive amplifiers that you can buy to operate that I'm aware of. Again, once you want to check it when you're close, plug them in, and there we go. That part of it's balanced. So that's the bias setting. That's the first thing we set. The next thing that we set is we need an oscilloscope. Hopefully we can see the scope running. And what I'm going to do is we crank this thing up to almost clipping. That means it's putting out over 300 watts. My dummy loads are only good for 200, so I can't run it too long this way. And we watch the scope, and then we adjust the driver balance control to make sure that these waves are clipping equally on both sides. It makes sure, especially for a bass, very important that the push-pull is balanced. So we don't need the voltmeter anymore. We're done setting bias. That's what you do first. The next thing we do is I think I've set to about, how many hertz? It's set about to 200 hertz right now, which is a good bass frequency. And here we go. You can see the scope. Cranking her up. And I'm going to get that waveriness you see is because we're close to I must have been close to a harmonic of 60 hertz. It's the capacitors. And we're going to have to give it a little bit more to clip it. There we go. That wiggling, it's starting to clip. And what I'm going to do is adjust this so that you'll see how the wave's misshapen? We're going to get this thing symmetrical. I'm going to give it a little more here. There we go. Get it so she's just clipping. We'd like to get it off of that. There we go. You get it to clip. There we go. And we're going to center it. And that's all this balance control does here. See, that's off. That's way off. It's also the quietest point. When you do this with an amp, you can hear the laminations in the output transformer hum. And the balance is set properly when it's the quietest, because what you're doing is something to do with reducing the standing waves in the, it's physics that's beyond my ability to explain. But when the transformer is the quietest at full power, that's when you have this balanced. The last thing we do is set the hum control, which is the heaters for the tubes. It's a balance control to try to eliminate AC hum. We need a speaker to do that, so I'm going to put it into standby, and we'll hook up a speaker, adjust the hum, and then we're going to test it with a guitar because this thing should be done. My dummy load resistors are extremely hot right now. I wouldn't want to run them very much longer like that because I will ruin them. All we have to do is set the hum. I'm going to plug in a speaker cabinet, and over the noise of this fan, it's going to be probably hard to hear the hum in the camera, but okay, I'm going to take it out of standby. There went the lights of the city dimming again, and I'm going to adjust this for the least amount of hum coming out of the speakers. Right there, this amplifier now has its bias set, it has its driver circuits balanced, and the hum control set for minimum hum. So we're ready to try it out with the guitar. Alright, I've got a guitar plugged in to the SVT. I'm just going to give it a quick test. That's not really the point. SVT sounds good. In humbucker mode, it's quiet except for that airplane-like fan. I checked all the tone controls. The pots are clean. The channel's definitely no longer cutting in and out. So, looks like we got it. Again, I'd like to spend a little more time inside of this, but we got to show you how to set it up, what it looks like inside after 50 years approximately. Sorry that I didn't get the year. The pots were kind of filthy, and as I said, I need to get this thing wrapped up and get to bed. So the amplifier has been running for several minutes, and one final test is output wattage. I have it hooked up to a 4 ohm dummy load and a scope. I turn it up until we're flat topping the waves a little bit, and we have 36 volts into 4 ohms. And wattage is voltage squared divided by resistance, or impedance, but in this case it's resistance. So 36 x squared divided by 4. It's a cool 324 watts it's putting out. It's a heck of an amp, it's in good shape, and we got it. And I'd like to go through it, tune it up completely, but it's working, and we got the problem fixed. Thank you so much for watching. We'll see you real soon.